Hello, my name is Roslyn and I'm going to talk about the role of CYP2B6 in metabolism and toxicity of efavirenz. Efavirenz is a non-nucleoside reverse transcriptase inhibitor used as part of a regimen in the management of HIV infection. It is also used in post-exposure prophylaxis. The drug is used in combination with lamivudine and either zidovudine or tenofovir. Metabolism of efavirenz is mainly by CYP enzymes, which include CYP3A4, CYP2C9, and CYP2B6. The main route of elimination is via CYP2B6, which is a polymorphic enzyme, and some of the variants in the CYP2B6 gene have been associated with low capacity of the enzyme to eliminate the drug. Of importance in efavirenz metabolism is the single nucleotide polymorphism from G to T on position 516 of the 2B6 gene. This has been associated with high plasma concentration of efavirenz, which have been directly linked to CNS adverse effects. Efavirenz has a narrow therapeutic window ranging between 1 and 4 micrograms per ml. And in the case of having concentration below 1 microgram per ml, drug failure in treatment or drug resistance may result. In the case of having concentrations above 4 micrograms per ml, there is a higher risk of having toxicity. In patients on efavirenz containing regimen, it has been demonstrated that patients with the homozygous mutant state, which is the TT genotype, have higher levels of plasma efavirenz as compared to those with the normal or common genotype, which is the GG. In the GG genotype, patients fall within the therapeutic window, but however, in the GT, there is the further role of the gender, where males fall in the therapeutic window, but females show higher plasma levels of efavirenz, hence are at a higher risk of also developing side effects. So apart from the genotype, there is also the contribution of other factors such as weight as demonstrated. And apart from the 516G to T variant, there are other variants such as the 983 T to C, which is the defining SNP of the CYP2B6*18 allele. This has also been associated with reduced capacity to metabolize efavirenz. The frequency of the CYP2B6*6 is high in African population and has been reported to be as high as 49% as compared to Caucasians, which is 29%. And African populations, being at the highest risk of contracting HIV, are even at a higher risk of having CNS adverse events as compared to Caucasians and other populations. And the genotype has been shown to be the greatest contributor to these CNS side events. The variation in the 2B6 gene accounts for about 20% observed variation in drug response. Therefore, there is contribution from other factors such as the weight and the gender, and this has been demonstrated in many publications. Clinical trials have also demonstrated a strong association between the genotype and the drug concentration. Therefore, before a pharmacogenetic guided dosing algorithm can be developed, there is need to take into account the genotype and also other factors into account. And with many genotyping techniques available, it is feasible to do genetic testing for patients prior to them being on efavirenz containing regimen in the same way as it has been done for abacavir. However, there is need to optimize the algorithm to take into account other factors so that the impact of the genotype is not over predicted. So these are some of the references I've used for my presentation. Thank you.